Good morning, everyone. So today will be our discussion mainly in the interview related. So before that, anybody having doubt, we can discuss. So today, at least those who are topic not cover, latch up, shielding. So many questions are asking from latch up, shielding. Even I'll repeat this. EMIR, layout dependent effect, all are will be covered today. If not covered, tomorrow will be extended. But latch up, shielding, I'll cover today, and some layout fabrication maybe tomorrow. Fabrication again I'm repeating, already I cover, but is some topic left like HTA, but this thing also will be covered. As many people are attending interview, so some people interview are scheduled in Monday. Okay, so any interview question you face difficulty, you can ask now. Any question, even it is not covered. Anyone want to ask anything?
Hello. Hi, sir.
Yeah. Yes. Yes.
This is Yashwant. I'm a new join. I joined today only.
Okay, so for new people, you no need to worry. We will take a backup class, and even tool also will given because some people also join, so they are attending interview
Okay, sir. Okay.
Monday.
Thanks.
So except you,
Thanks.
any other new joinee are there? Okay, so you have studied this is Cmos. So Cmos means complementary mass. So each terms you will go in the interview also. They are asking KVL, KCL also. So even what is KVL, what is KCL, what is network, voltage division rule, current division rule. Kirchhoff's voltage law means sum of the voltage. When this is interview discussion, they ask sum of the voltage across a node equal to 0. Similarly, sum of the current across a. This is in loop. Okay, let it be understand. So this is loop and node. So definition, when you are giving anything, it should be specific. You just don't need to mug up anything. This is around. This is a loop. Loop means this is a loop. So whatever the voltage, suppose across this resistor any voltage, or this is like a voltage circuit. So all the voltage if you add, you will get 0. Similarly, current node means this is the node. All entering or leaving anything it will be, or all the current if you add. So I1, I2, I3 to add, it will be 0. That condition should be satisfied. Next point. Come to our discussion. So today we will be cover latch up. Okay, so what is this latch up? Has to come to our tool. In the layout, I'll check this. You might have everybody have seen this error. Okay, so this is PMOS or NMOS. I didn't connect the body. Suddenly, if I run, you'll get the DHC. So this is latch up error. So two type of latch error getting. P plus SD means source to drain to annual tab spacing must be less than equal to 25 micrometer. Okay. Second error N plus. So this is your N tab, this is a P tab. P tab to N tab to P sub tab spacing must be less than equal to 25 mm. So what does it is meaning? So just this is a PMOS. PMOS means, okay, let's already I discussed for PMOS. This is your P substrate. This is your NOL. So this is your P channel mass means P plus here N mass. So this is NOL. So your body is N plus. But layout it is called N tab. So PMOS will take a N tab. So you need to, this is a PMOS. You need to add N tab. N tab hide to draw. So what is asking? Just go to error window. P plus source to drain to annual tab spacing. So this is source or drain here. So you will measure up to 25 micrometer. So this is 5 micrometer. All are in micrometer. So if I after 40 micrometer I have place, if you run DRC, that error will not clear. Understand? So it should be range in the 25 micrometer. That also I will tell you why they are asking 25 for this technology 25. Some technology it would be 20, depends upon thing. But when you understand latch up will come without tab, latch up will come. That is a blind route. Or anybody having doubt here. Okay. So first to understand what is this latch up error. I'll first write the latch up definition. So latch up refer to short circuit path formed between power to ground. Okay, it's a little bit book definition. When across VDD and VSS and power and ground. Okay, or a short circuit path when you can kept here. When there is Now at what time it will be created? Means short circuit path within BJT basis. When it will be created? When there is a parasitic NPN and PNP BJT form. Understand? The main point is now parasitic BJT. So this BJT we need to discuss about when this PNP BJT first this will be formed, then there is a short circuit. Means it interdependent. Means Y equal to mx. First x will be created. If you multiply something, y will be created. Means y is function of x, dependent of x. Similarly here, in BJT, this short circuit depends upon the formation of the BJT. So first which one will be created? BJT. So we need to understand how this BJT will be created. Before we going to understand, first to understand the structure of BJT. Understand? I'll not go that much depth. BJT. So BJT having three terminals. So what are terminal? Emitter, base, collector. Having three terminal, emitter, base, collector. What is the function of emitter? Emit means emits electron or maybe hole, proton. Collector, it will be what will be collect. Base is a control circuit. So it is, if you relate with MOSFET, it is like gate, source or drain. But second point, emitter is a highly doped. So in a initial class, doping. Dope means here in the small area also, the current density, sorry, not about current, density of a electron hole will be more. Suppose here density of electron, let assume 1000. Collector is moderately doped, so it will be 850 number of electron. It is lightly doped, so it will be like 100 or 50 number of hole or electron. I'll come to that point. Then if it is NPN, NPN, so these are will be electron, this will be hole. Okay. Up to now, anybody having doubt? So what is the minimum condition required? It should be doping concentration should be high of the electron. Collector will be moderately doped, or even it is lightly doped. Okay, let even collector also lightly doped. This current will be transferred because why? As you know, this is taken as a bucket. So this bucket is full of water. You connected a pipe. This bucket having this much water. So what will happen? This water automatically will be transferred. So this concentration from higher concentration region to lower concentration region. This is the automatic flow. We are not applying any external force also, it will be electron will be flow. If it is given, some path will be there. This process is called diffusion. So anything like higher concentration to lower concentration. This is the, like you can tell, this is the natural thing. Similarly here also. But if it is same level water, so what will happen? This is the both are at an equilibrium condition. It is not possible. So now this thing will apply in our Cmos. If anybody having doubt, you can ask me in between. The structure of a Cmos, how it is looks like. This is your annual. This is your P substrate. So this is your Pmos. This is your NMOS. So your body will be there. Every interview latch up will be asked. So try to understand. I am trying my best to you people will be understand. If you are not understanding, you can ask me. I'll repeat also. It's like an inverter. How will be connected? Source drain will be connected. Okay. Okay. Let's forget about tap. Even you don't add also, what will be happen? Okay. Forget about. You will not adding tap also. First case without tap, latch up error is there. So how we will need to understand it is latch up error. Okay. So you show that is this is P plus. Okay, I am drawing like this. Why it is P plus act as emitter, NOL. So this is a NPNP. P the P plus NOL. This is P substrate. Here NPN. N plus P substrate N. Which one is the emitter? Okay, somebody asked why. Okay, so how many BJT will be formed total in this CMOS? You can take this one also, here also. This is also one type. So 4 BJT will be formed. Okay, next point. But we are main considering about VDT VSS because this is the critical point. We are considering about. We are not considering about this point and this point. So BJT will be formed, and the short circuit path, the current will be, see, this is the path where current will be turned. So this is the path where current is flowing. This current is called latch up current also. Unwanted current. Why? The normal direction current will be flow in the channel only. This is the connected gate. Through channel will be created. Here only it will flow. So metal will be connected here. but in the substrate current is flowing, the device will be warned. So due to the latch up, device will not operate. So latch up error should be clear. Understand or not? What is the definition of latch up? The short circuit path is creating between the parasitic BJT will be found. Due to this BJT will be found. So BJT purpose means how I am telling this is BJT. Emitter I told first this is BJT because plus is a emitter highly doped. N is a lightly doped. P substrate also lightly doped. That's why BJT will be found. There is PNP BJT. Here NPN BJT. N plus is a highly doped. Lightly this P substrate and NUL both are having lightly doped. But due to the doping agent, current is flowing and you are applying some external voltage. Second condition also I need to tell. So you are applying some external voltage. So it will be forward bias, it will be the more number of electron will be transferred. Any doubt till now? Next point, how adding the tap we are removing avoiding latch-up error. Means latch-up error means we are avoiding this current. So if these two devices, if you make cutoff region, we have saturation or a linear region or cutoff region. For operation, current will be flow to region means either linear or saturation. Understand or not? So if you make both two cutoff region, then current will not flow. If this one is causing your BJT, even BJT will be formed, but it is always in cutoff region. So we have to make these two region always cutoff region. Understand or not? How you can make, that is the discussion. Abhishek, Ashok, Guru Raj, anybody having doubt?
No, sir.
No, sir.
Okay. So for this we need to equivalent diagram. So now by adding tab will be, so we need to add this tab. What, see, so here also some register. So this will be some path will be creating. We'll make this the equivalent circuit. How? Current entering. So this point current entering, it is connected to VDD. Another path is, so I have taken all together annual resistance at a taken 1 point everything, and it resistance across R annual. It is also connected to VDD only. This one also connected to VDD only. Second path, this resistor is PNP. NPN. another two path is connected to VSS. This one is connected to VSS, this one VSS. So where I am taking RP substrate resistance, it is having some resistance will provide. The lightly doped means resistance will be very high. R annual RP substrate. VDD and VSS. Okay, let you draw this one. Okay. So our main aim to remove in cutoff region. So let's understand one point. VSS means 0 volt. So this is having RP substrate having very high resistance. Let's assume this is 1 mega ohm. Or you can tell this is P substrate resistance. If you connect it directly. In terms of mega ohm. Current also. So what is BJT condition for VP for less than 0.7? That is called cutoff region. If it is VB greater than base and emitter voltage greater than 0.7 for silicon germanium 0.3, generally silicon we are taking 0.7. If it is greater than, then you will be act as active for saturation. Anything you will be at, that is fine. Okay. Next point. So our main name VV less than 0.7. And this is the current also not that much high. It will be less because these are in the substrate region. Substrate region will be carry in microampere, even nanoampere also. So very less ampere. Let's assume the current also going because this is high resistance path. Current will be less on this micro, but current will be flow here the high current because resistance will be less. As you know, two paths. Okay. So somebody having doubt in the parallel. Let's assume this is 5 volt and this is 1 ohm. One resistance is 1000 ohm. So in parallel voltage will be same. So here it will be carry 5 ampere. 5 divided by 1. Here how much? 5 divided by 1000. So 5 milliampere. See, same voltage you are applying. This is in milliampere, this is in ampere. So now you got the clarity. So here it is going microampere. So let I am giving the example 1 microampere. So if you multiply micro into mega ohm, so it will be 1 volt. So this terminal is base. This is your emitter. So if you subtract base voltage is this voltage you got 1 volt. Emitter voltage directly connected to ground. So VBE you can write VB minus VE. So VB voltage is 1 volt, VE equal to 0 volt. So which is greater than 0.7? This is what is this analysis is without tap. So now if you add the tap, if you see it is inside. If you the layout also you see it is doping concentration is high. How will you understand it is having more number of contact? Okay, and the implant also there. You are writing P plus or N plus. That is doping concentration high. So if you doping concentration high, what will happen? The resistance of this it will be reduced. So instead of 1 mega ohm, let assume some parallel resistance. Okay, so in parallel resistance will be reduced. We are adding some resistance here. Suppose this is 1 ohm, another 1 ohm. If it is parallel, how much? 1 into 1 divided by 1 plus 1. 1 by 2.5 ohm. So it is reduced. Series additive, whatever in parallel, it will be reducing. That is the concept. Similar doping concentration means the resistance will be reduced. Conductivity will be increased. So resistance reduced means let us assume reduced to 0.1 mega ohm. If you multiply 1 into 0.1, you will get 0.1 volt. So VV voltage is 0.1 volt, VE is 0. So 0.1 less than 0.7. So this device will be cut off region. Understand or anybody having that? I am just repeating this point. Current will be same only. So I am not changing any current value. So resistance are reducing by doping concentration high. By adding tap. So this is the resistance reducing. You can tell in the interview. So how adding tap will be latch will be reduced. So because the addition, you can draw this diagram and tell this is the example to make the cutoff region. The resistance of the substrate resistance is reducing. So with the reduction, it will be achieving cutoff region. This is for NMOS, PNP, NPN. For this condition also I'll tell you. But anyhow, before that, anybody having doubt? Okay, this is a PNP. R renewal, assume this is also 1 mega ohm. VDD voltage is 5 volt. So this is here. Emitter potential is here. This is a base. Okay. So what is current also 1 microampere. So this is 5 volt. There will be some drop. Drop is 1 volt. So 5 minus 1, 4 volt. So emitter is 4 volt. Sorry, base voltage is 4 volt. Emitter is directly connected to 5 volt. But remember, this is a PNP. So instead of VB, you can take modulus. Mod is greater than 0.7. For active region, less than modulus you can take. Or some book it will be given VEB. Just reverse it, the voltage. That is also fine. So our time taken, VB equal to 4 minus 5. So its modulus is 1 is greater than 0.7. Understand or any doubt? So this is the resistor. This is a current 1 microampere. To multiply 1 mega, 1 volt. This voltage is 5. So as you know, this is 5 volt. This is 1 volt. So if you 5 minus 1, at this node it is 4 volt. This thing I am just telling. Okay. So this is in active region. Now if you increase this resistance, reduce the resistance by adding P tap, R renewal, na, so resistance will be reduced. So here also same thing like 0.1 mega ohm. So what is the voltage now? 0.1 into 1 milliampere. So 0.1 volt. So 5 minus 0.1, you will get 4.9 volt. Emitter volt, base voltage. 4.9 volt, emitter voltage is 5 volt. So VB minus VE minus 0.1, its modulus will be 0.1, which is less than 0.7. So now it becomes cut off. Understand or any doubt? By adding tab, you are avoiding STA. So this is all about latch up. Only one region we can do how to avoid latch up. Second condition, you can do STA also, or you can maintain a distance between PMOS and NMOS. So what is happening in between? Short circuit is creating between PMOS and NMOS. If you place this device little longer, but this is not a good suggestion. Why? Larger distance means you need only area minimization. So why are you keeping lots of distance between them? Simply area will be increased. So this is not preferable. Second condition. Third condition, STA. So what is STA full form if we see? Okay, before the latch up, anybody having any doubt? Are you getting or only it is bounce? Okay. So STA means this is just a isolation between two active devices. But trench mean little bit different. The mean is meaning in shallow trench isolation. Name itself is suggesting that. So suppose these two devices. Any PMOS and NMOS. So there is a chance of short circuit will be occur. So STA means inside this device it will be no substrate will be there, only Si2 layer. Means Si2 layer dielectric will be. Dielectric is like an insulator. If you kept insulator, the shape will be little not this type of. So what will happen? This short circuit current will not flow. So you will add this IO2. So how it will be forming? Thick oxide layer you are adding. The electrical leakage within two adjacent semiconductor. This is how form. First air substrate is there, above it Si2 layer there, then this green is a photoresist. So you are removing photoresist, SiO2 layer, then you are adding. By etching you are removing this layer, Si2 layer. So this is the internal starting class I already told. To remove Si2 layer you are using etching material. Means hydrofluoric acid or some plasma etching. Plasma means dry etching. So after removing you are so you will do little bit inside this. So photoresist remove, this is the photoresist. Remove step by step. Next step this one also remove SiO2 layer. Then they are adding the filling trench with CPT, chemical deposition. CMP also tell. After that, some polishing will be there. You are removing like this. After doing polishing, chemical, mechanical polishing, chemical vapor deposition. Because this is our in liquid form. This is. Now this is the about HTA. So generally, sometimes SiO2 layer or some metal there will be nitride. This is also insulator. Not nitride. SiO2 will be there, but they will use some nitride layer here side because nitride will not react to atmosphere easily. Protective nitride. See, this layer is called. So here three layer. Okay, so some people will not understand. You will see one layer, second layer, third layer. So first layer is SiO2. Third layer is nitride. Then photoresist. So first you remove photoresist, then nitride, then SiO2. For nitride, already here you can use photoresist. For this remove photoresist, you can use positive photoresist or negative photoresist. To active device, you are using STA. This is share. If you don't share, you will be there is a gap will be there. So that time you can use STA. But anyway, this STA you will not see here at the time of fabrication. Clear or any doubt? Two concepts we clear. We will go to shielding, then we will go for like layout depend like antenna effect and EM. That is the target today. Tomorrow all interview question matching will be covered.
Sir, why two dummy gates?
Yeah,
Hello?
dummy thing I'll cover the WP and matching.
Okay, sir.
Mostly tomorrow we'll cover. At the time of OPAM we'll discuss means matching thing. But tomorrow I kept for only dummy everything will be covered.
Okay, sir.
Okay, if time permits I can give. Any of some shielding. So what is this point shielding? Why we are doing? And one guy shared that question. Out of three signal, which signal will to do shielding? So first to understand shielding. So shielding to protect from parasitic. So parasitic means capacitance. So capacitance. Suppose two metal is there nearer by.
Sir, parasitic what?
Parasitic means capacitance on. Okay, so what is parasitic? Actually, why it is called parasitic thing? So two concept. One is victim Exact term I will tell you. Okay, so before that point, yeah, parasitic I will tell you. So parasitic means suppose this signal is going, you connected some PMOS. Okay, so these are nearer main. So what is capacitance C equal to epsilon A by D? So another, it is connected to some NMOS. Two metal, two you connected, and it is connected. So due to this, what is happening? A parasitic cap will be formed. Parasitic means near adjacent cap, which is unwanted. On noise means what? Unwanted signal that is called noise. Similarly, parasitic cap. Parasitic also like unwanted. Unwanted means due to this some signal will be transferred to here. Also, it will maybe create some delay of this signal. There is many effect. I'll give you some one example how it is creating. This is the parasitic. Parasitic means adjacent cap which is unwanted, which we don't need this thing. And by this cap, what is happening? So this signal is, this device will be turned on at 10 nanosecond. This time period 10 nanosecond. This time period is 20 nanosecond. Then this device will be turned on at 20 nanosecond. This 10 nanosecond. But due to the cap, what is happening? It will be adding some delay. So it will be adding delay means it will be turned on at 30 nanosecond. So after some delay, this device will be turned. So this is called your parasitic. Understood?
Yes, sir.
Okay. Next point is like two signal is going. One will be aggressor, another is victim. What is aggressor and victim? Means somebody, victim means what will be affected by the noise. Previous example, so this capacitor is affecting, this is the victim. Victim means this time signal is reducing. This is the aggressor, this is the victim. Now first identify between aggressor and victim. That also I'll tell you. Means someone is causing damage to another signal. So which is causing? First to see. So let two signal, let one is like a deep flop. When I discuss the flop, you will understand. So flop having clock signal and data signal. Or any voltage signal, anything is there. So out of this, clock signal is very critical because this time period, this device will be turned on, depends upon clock signal. If data will become 1-0, it will not that much affect. If this data 0 will become, if a device is turned, anything like 1-0, either 0 or 1 it will come. Okay, but clock signal is very important. If device is not operating, now even if data is come, what will no use? Data will be transferred from input to output. But first device should be turned on, only then data will be transferred. First point, this one clock signal always a victim signal. Understand? Next point. Shielding means where if you meaning of the shield means protecting cover shield. Like you are playing the cricket match. So what is the shielding? You are using a helmet. That is your protecting from here. Similar in the layout also. Who is your protecting? So first I discuss what type of shielding, how it is affecting. Let's take an example. Shielding is two type. One is sidewall and second is the coaxial shielding. So what is this sidewall? If you are protecting only top or bottom, in both side, that is called sidewall. Second one is coaxial, all side. So that is called coaxial shielding. I'll show you in the layout. So this is practically also you need to see. I draw a metal one. So what is sidewall? You can use same metal. You can take minimum spacing, sometimes 2x time. 2x time means 2 into minimum spacing. So minimum spacing 0.12. So 2x time means 0.24. Top or bottom you will draw. This is actual center one is the actual signal. And you will not floating these two signal, you will connect it to some potential. Like a GNT, which potential you need to connect, that I need to tell later. This is called sidewall shielding. Next point is coaxial. So coaxial, let us assume here M2 metal. This is you want to shield. Top or bottom you will draw same metal, but M1 and M2. Which is the below metal? M1, just higher next higher metal M3. So for M1, what we will do? This is for M1. For M3 also, you will draw same thing. So this is like protecting all side. Use auto via. See, all side is protecting. So this is your actual signal. So in the PPT also, M2 parallelly M3C, all side it is covering, M1 all side. Okay, next point, where you need to connect shielding point. Two point is less, it is connected to PMOS. So PMOS channel which connected 5 volt. This net voltage is 5 volt. Okay, so now you do it shielding. Top or bottom you do it side wall shielding. This shielding line, this is the one line, second line this. So where which potential you need to connect? It should not be floating. So if you connected 0 volt, ground you connected by default. So what is the formula? I equal to C dV by dt. So this is the capacity current. So this current formula is I equal to C, the capacitance value, depend voltage difference. The voltage difference means this is 5 minus 0. So current proportional to 5 minus 0. Okay, so it will be high current, but suppose I will tell you this voltage is 4.9 because some resistance did not exactly. You connect it to VDD 5 volt. So what will happen? I directly proportional difference between two potential, higher potential minus lower potential, so 5 minus 4.9. So it is 0.1. So you will connect a huge potential. So out of this, which one is current less? That will be good only with this unwanted current. So if you connect it to VDD, this current will be less. Understand or in doubt? So which one is preferable? You connect it to VDD. If it is this net is connected to PMOS. If this connected net is connected to NMOS, that time you connected to VS. Understand or any doubt?
Sir, can you repeat it one more time, this point?
Sir, I didn't understand the whole process, sir. I mean, exactly how is it shielding and all?
Yeah, I am repeating again. So shielding to avoid the unwanted noise. Okay, let's take an example. You connected a metal. In this, if you understand layout, this is a PMOS net. You connected some routing here or clock signal you given to another signal, another PMOS also there. You given some data signal. Okay, so what is happening? This is due to this data signal. What is This device is not turned on at a time. For you can 10 also, this is connected to gate only. Let assume this is connected to gate. Means device will be turned on at a time because of this gap. Because of this gap. Understand? So this device having some delay. You want suppose your let's take an example of your mobile phone. You did your layout. Your chip is designed by your 7nm chip, or anything like Qualcomm Snapdragon you purchase. So if you see every time they are changing 865, 9 even future they will be 845 like that they are designing. Why? Because these are the improvement. Suppose you are charging your mobile phone, your processing speed will be CPU will be good, but mobile phone is taking actually they are writing 30 minutes it will be fully charged, but due to some delay it is charging your 1 hour. Why? Because when they are doing processing, this type of delay thing means the routing needs this is creating some parasitic gap. Understand? So how to avoid this? You are sending signal 30 nanosecond, but it will be turned on at 30 second. Why there is this type of delay? This delay is called
Sir, so the delay now is because of this parasitic capacitance or what, sir?
parasitic capacitance.
Okay, sir.
Okay, so we need to avoid this thing. So in the layout, I told you two type of things you need to do: sidewall and coaxial. By doing this, what we are avoiding, how we are avoiding, let's see. Okay, one is red signal I am giving. So initially these two signal capacitance is there. So by shielding, so okay, 2 point. This is your data signal, clock signal. So already I told you data is the aggressor, this is a victim. So tell me which one we need to do shielding, aggressor or victim?
Victim, sir.
No, this is the wrong concept. So why victim will be if you okay, let assume we are doing victim shielding. So even the victim you are doing shielding, what will happen? The capacitor, metal and metal capacitor will be increased. Even it is also same thing because this capacitance delay will be there. Understand or not? Because the
Yes, sir.
yeah. So which one causing the delay thing? Aggressor. So if you protect first aggressor, due to this aggressor and these are connected to lower potential, this line will be not create noise because you are connected to ground or generally okay that will tell later. So you connected to this is the selenite. So whatever the noise signal is generating from here, it will not come because this is the only causing. If these are covering, let us assume I will give you in better way. One signal is this clock signal will be okay. Clock signal so this is like this. Noise means you are getting this is your unwanted noise. Means sometimes you are getting 4 voltage. Actually 0 4 is the correct one. But if you remove this in output you will get exactly same time. Your time period will not change. Understand?
Yes, sir.
So this unwanted noise will not come. So if you are protecting this by using shielding, so this noise will not come. So how to protect this type of two type of shielding? Always remember, if in interview also, if one is data signal, another is clock signal, so you have to shield first data signal because that is the aggressor. Okay, and which type of shielding? See, if it is more critical, go for coaxial. This is you need to ask the designer. So when you do shielding, so which shielding you need to do? You need to ask the analog design people
Okay, sir.
because they can tell even the voltage thing also they will not tell. This is not our role. They will tell you can go for this is a critical signal. Then you can tell I will do coaxial shielding. So coaxial shielding means if it is M2, you will use same material top or bottom and M1 and M2. If it is M3, you can use M3 top or bottom covered by M2 and M4. That is coaxial. For side one, okay. Even sometime they will ask two clock signal also there. So this is a data signal clock signal you are using to identify. Suppose two clock signal also there. So which one will be do shielding? Now we will compare the frequency. Frequency means if it is low frequency, one is high frequency. So high frequency means suppose is gigahertz, one is megahertz. So gigahertz means in nanosecond it will be transferred 10 to the 12 and megahertz means millisecond. So we need to shielding this one. If you do shielding, do not have high frequency signal, don't shield because if some delay will add, it will convert it to it will be very fast turn. Means this two signal is causing generally it will be very less chance to clock signal, but the fast data signal will prefer. If two clock signal is going parallelly nearby, so there is the last option. Go to lower signal because high frequency signal is very critical. Why? Because time period if you see it is in 10 nanosecond. Within very short period of time it is transferring. Okay. Understand or any doubt? I think Sendel all question I cover. You don't need to worry. Beyond that, they will not ask any. Okay, I'll touch now current mirror. because matching concept every time enter. So before that matching, we do know current mirror and differential pair. So what is current mirror? So before that op-amp also I'll tell you. Op-amp means I try to little bit shorter. So op-amp input, okay, V1 minus V2. This is output. So V out equal to your gain V1 minus V2. So difference between two voltage, your gain V2. So operational amplifier. Op-amp, what is the use? Amplification of the voltage. So who is amplified? By using the gain. And this op-amp will be designed by current mirror and dip pair. So this op-amp class will take a 1 day. So I'll do next week only op-amp will be start. Before that, I'll give you for whatever interview purpose, whatever required, I'll cover. Because Monday, many people are going to attend interview. Am I correct now? Monday, how many people are there?
Yes, sir.
I think Capgemini interview. Some people having completed. That's why I need to discuss interview question. So for everyone, it is also required. So we need to design op-amp using Cmos, minimum PMOS and MOS will be there. So op-amp will be carry current. So if you carry current means here V2D and VSS. And this V1 minus V2 designed by dip pair, differential pair. So today I'll discuss about current mirror. So current mirror, two concepts will be there: source, drain. So how to identify this is a current mirror? So current mirror means whatever this side current, so this is 2 ampere. So automatically, no need to pass any current, it will be automatically this is also 2 ampere. So how it will be this 2 ampere, we need to prove it. Okay. So to current mirror, we have two conditions. So one is gate and drain should be sorted. So if gate and drain sorted, so whatever the voltage aggregate, drain voltage should be same. Condition 1, gate and drain should be sorted. Second case, VGS1 equal to VGS2 means gate to source voltage of the first device, gate to source device of the second device should be same. If these two conditions satisfy, then here both current will be same. And why these two current will need, that also I tell you. What is the current equation? You know, you can take the saturation region 1 by 2 VGS minus VT whole square. This is a drain to source current. Use the mobility thick gate oxide W with length VGS minus VT. All these are term constant. I'm just taking IDS into K into VGS minus VT. Even W if you change, that will be changed. For time being, I'm just telling VGS minus VT whole square. Okay, this is the first current. Second is current IDS2 equal to K VGS2 minus VT whole square. IDS2 is threshold voltage same by which we connected one point. So VT also same. VT same, VGS same. And why VG equal to VD? What is the condition for saturation region? This is you understand. Current should be same, so that's why VG is equal to VGS2. Second condition, for this condition, this is saturation current or linear current. What is the condition? VG is greater than VT. Next condition, VGS minus VT. Understand? So now if gate equal to drain, so VD equal to VG. What is happening? I can write VDS minus VT because VD equal to VG. So if this is 5 volt, so 5 minus 0.1, this is also greater than. If this condition satisfying, VG is greater than VT, VG greater than VGS minus VT. So this is saturation region. So to make saturation region, what do we need to do? VG equal to VD. Understand or any doubt? So if these two conditions are satisfying, I think nobody having doubt. So if this is 2 ampere, this is the same because this current equal to this current. How? VG is equal to VGS1 equal to VGS2. So if you put this here, so this if you divided IDS1 or IDS2 equal to IDS1, all will be cancelled. So K divided by IDS1, so it will be cancelled. So it will be 1. So IDS2 equal to IDS1. Understand or any doubt? This is the current mirror. Let I'll give you one example. Okay, next point, why you are connecting like this? That is also you need to ask. How VGS1 equal to VGS2 in this circuit? Gate drain we have started, that is easily. So this point, if you see, and this point gate source, if you started this point, this is in parallel. So parallel voltage will be same. So this is VGS1, this is VGS2. So VGS1 equal to VGS2. This point to this voltage same, this voltage, this point same. That's why it is connected to VDD. Understand or not? This source you have to sort. Then VGS1 equal to VGS2.
Sir, last thing one more time.
Okay, so this is A point, this is B point. there is no point, this is also B point. So A to B voltage is 5 volt. So can you tell what is this to this A to C? What is V voltage? Same voltage. Why? Because both having parallel, always remember in front of parallel, the voltage will be same. Understand or here any doubt?
Understand, sir.
So similarly, if you apply here some voltage here, this source point, this is a gate point. So I connected one voltage. I can short this point. So this potential equal to this potential. So this terminal is source 1, this terminal is source 2. Gate anyhow go to one point only.
Now I get it, sir.
Okay. So to make two condition, VGS1 equal to VGS2. Second condition, gate equal to drain. So this is the minimum condition to satisfy current mirror. Now in interview, what they will ask? I go to directly in the Samsung what they ask. So calculate the resistance value. So what is the answer?
0.5.
Yeah, correct. Okay, so 0.5 how it is. So you have to find what is this current. So current mirrors same current, but what is W by L? 2 times W. So come to current equation. If you see, idea is 1, W by L is there, VGS 1 minus VT whole square, K constant divided by 2. I am not mu Cx by W. For K, that all value I am taking K. For IDS 2, K 2 W by L, VGS 2 minus VT whole square, but VGS 1 equal to VGS 2. Now if you divide, this will be cancelled, this will cancel, this will also cancel. So IDS 1 equal to IDS by 2, IDS 2 equal to 1 by 2. So IDS 2 equal to 2 times IDS 1. So 2 times means here IDS 1 is 5, it is 10 ampere. Okay, this is like a parallel circuit. So 5 into 1. So what is the voltage? 5 volt. So here also same 5 volt. The resistance equal to 5 divided by voltage divided by current 10. So it is 0.2 ohm. Sorry, 0.5 ohm. 1 by 2 equal to 0.5 ohm. Understand or anybody having doubt? Okay, let's assume because this will take little earlier we are just starting. So M equal to, that is a concept, multiplier and finger. So this is 1 ampere. So what is this current? Okay, so before that, multiplier means one device having suppose let us add Cmos W by L. So multiplier, 2 multiplier means it will be connected like this parallel. So instead of connecting 2 times, it will be suppose 100. What will we do? So instead of connecting parallel, we are writing M equal to 2. And remember, W by L remains same. It is just a replica. This is called multiplier. Okay. What is finger? This W will divided by, which will divided by number of finger. So how will be there? Like in layout, how will see this is your length, this is your width. So 2 finger. So we will divide it by width. This is W by 2, W by 2. If you add this to W by 2, W only, this is 2 finger, 3 finger, W by 3. And this is addition, that's why it will be series. So finger in series multiplied in the parallel. Sometime in the interview they are asking what is multiplier and finger. You can take an example, you can tell them. And the layout you can see. One example is multiplier. So I will give you 2 multiplier. See, 2 device, it will be same come. It is called multiplier. Exact same time. For finger, I did 2 fingers. If you launch the layout, this is the finger. .360. It is 720 if you see. Total width is 720. Finger width is 360. Number of finger 720 divided by 2, 360. 0.36 means 360 nanometer, which is divided by 2. Okay, come to our question. This is 1 ampere means this multiplier 2 times is connected parallel. So 1 ampere plus 1 ampere, 2 ampere. So this is 2 ampere. This is 3 ampere. So total current 6 ampere. Any doubt? Multiplier finger. Today we discuss latch up, shielding, multiplier finger, current mirror, different pair. Tomorrow matching, layout dependent effect. If you know that much thing, and fabrication, just revise fabrication. And tomorrow, for coming tomorrow class, I have given the recorded class in YouTube or when it is shared in the group also. Interview question video. Just see that. Today you just watch this all interview record session. So maximum class. So you will not face any difficulty in the Monday interview. 90% syllabus will be covered. Okay. And some interview they are asking what is Excel connectivity. So what is the advantage of layout Excel? In the layout Excel, you will get the connectivity between schematic and layout. This is the first point. Suppose is the advanced version. Advanced version means suppose you will do, take example here, synchronous copy. In the layout L you will not be there. So this you can cross check. Suppose you can copy this F3, create synchronous copy. Or you can tell this is also a cloning thing. Everything will be available in the Excel. If you do in L, this option will not enable. Okay, if you launch layout L, I did copy F3. See, this synchronous copy option is not there. Understood? This is the common interview. Sometimes they are asking. And paper stick diagram sharing wherever there is not, that also you need to prepare. So today I'll stop now. Any other doubt? Okay, so before that one guy asked dummy thing. So what is dummy means? I'm just repeating. If you sort all clock drain gate, means it will be cut off region. What is the condition? VGS minus VGS should be greater than VT. But your gate and source voltage sorted. VG equal to VS. VGS I can write VG minus VS greater than VT. So if both voltage same, 0. 0 will never greater than VT. Okay, so this is your cut off region. Next, what is the use of dummy? Actually, I need to tell this is WP effect. Anyhow, I'm just telling you now. So what is WP? Oil proximity effect. So oil proximity effect, suppose this is annual you are creating. So how it will be created? This is by drawing. Sometimes even interview they are asking, why 7-degree tilt? This is the 7-degree tilt. Okay, so this annual how they will create? This is okay. So three type of process: ion implantation method, and annual will be created. So ion implantation in the fabrication process, one process is called ion implantation. So this ion will be okay. So if you go to forget about 7 days, you can do like this also. So suppose you are falling a ball, so it will be speed more if you go to directly straight. Understand? But when you did some angle, like if you see the projectile motion or your aeroplane, how it will be go? It will be travel like this. Then you have to fix. Then it will fall down. But if you aeroplane, it will never go like this. Understand? When flight will be take off, it will not be like this. It will be some angle. Depends upon the projectile motion formula. Similarly here also, when this electron will be come, this is the extra value. Actually, this formula is there. Some sine angle. If required, I will give you the exact formula. When light will be fallen with this angle, if you do, this is the uniform. And what is the if you do some angle? What is the advantage? So it will be front, then it will be like this. So this velocity will be reduced. Suppose you want only this 5 micrometer only. You don't want 7 micrometer. If you fall directly electron, it will be go little bit depth. Understand? But if you do some angle, it will be break at the oil. So at the oil, the speed will be reduced. Understand or anybody having doubt? Okay, so when ions will be means electron will be coming, it will be fall in the well. So when well the speed suddenly it will be stopped, then it will become little bit again it will be speed will be reduced like that become. But at the well the speed and the concentration of electron will be more. So over here 100, 1000, here 1000, but in the side it will be 900, 900. Okay. Up to now anybody having doubt? Like in the concept of the current mirror, if you see like 4 5 multipliers are there, or 3 multiplier means 3 Cmos will be there. Let example. Say from Cmos is there. So all Cmos will be turned on at a time because Vt will be same. So all threshold voltage will be same. So 0.1 giving this also will be same. But what is happening here? Electron will be 1900, here 1000 means middle portion 900. So due to the more electron, this is P plus means channel. You need to apply negative voltage. Channel will be greater, but the concentration of hole will be there 10 number hole. Hole remains same 10 number hole. But the concentration of electron is more. Like in cinema hall, if you see the people is more. People see 50 people are there. Now suddenly the movie hall is fully packed. You want to come outside the cinema hall. What will be? You need to apply more force. Similarly here also, this hole will be arranged in the different direction. To come out here, so what is happening? The obstacle is more. So you need to apply more force. So Vt will be increased 0.2 suppose. Here 0.1. Here also same 0.2. So Vt variation will be occur. Understand? To avoid Vt variation, if you side add dummy, the middle is 900, 900, side 1000. If these two device is dummy, so what will happen? this event point VT is 0.2, 0.2. There is no huge dummy operation will not occur. And these three active device, all VT will be 0.1. Understand, somebody asking me what is the use of dummy. To make VT, we are adding dummy in the side, left and right. This is the answer I want to tell. If any doubt, let me know. Okay, no doubt, we can close now. Okay, that's all today. Please prepare. You have attend interview. All the question you prepare. You will remember everything. Whatever I cover, they will ask in interview.